On the morning of March 12, 2024, a press release from University College London drops into my inbox. The subject line reads, "Why the gap? Genetics of tooth spacing finally decoded." I click it immediately, because I have a gap between my two front teeth. I've had it my whole life. A neat little window that my tongue has been poking through since I was a kid. And for years, I never thought to ask why. It was just part of my face, like the freckle under my left eye. But that morning, as I scanned the study summary, I realized I was about to get an answer that stretched back way further than my own childhood. In fact, it stretched back before Homo sapiens even existed. I'm going to tell you what that study found, and then I'm going to take you on a detour through deep time, through ice ages and medieval poetry and the sweaty armpits of a mutation that swept across a continent. Because, it turns out, the story of your gap teeth is also the story of human migration, survival, beauty, and a tiny piece of DNA that decided all on its own to keep your front teeth apart. But first, I should say, I am not a geneticist. I'm just a curious person with a diastema. That's the official term, from the Greek word for interval. And I wanted to know where mine came from. So I did what any reasonable person would do. I sent a tube of my spit to a consumer DNA company. The results came back, and among the hundreds of traits it predicted, attached earlobes, cilantro aversion, whether I'd flush after alcohol, there was no mention of my teeth. That struck me as odd. Why not? If the gap is written in my DNA, why couldn't a simple test tell me? The answer, I learned, is that the genetics of the diastema are surprisingly complex, and until very recently, nobody had been able to pin them down. Then I stumbled on that March 2024 study, published in Nature Communications, and it changed the way I look at my smile forever. Now, before I dive into the genetics, I need to warn you, this gets a little technical for a minute, but stick with me, because I promise it pays off. The study was a genome-wide association study, a GWAS, or what scientists jokingly call a gene hunt. The team, based at UCL and the University of Bristol, combed through the genomes of 521,000 people from the UK Biobank, a massive repository of health information and genetic data from British adults, cross-referenced with detailed dental assessments. They looked specifically at whether each person had a midline diastema, defined as a gap of more than 2 millimeters between the upper central incisors. Then they scanned for tiny variations in the DNA that correlate with that gap. In the end, they found over 120 different spots on the genome that contribute, each with a minuscule effect. But among them, one signal stood out way above the noise, a stretch of chromosome 2 near a gene called PAX9. PAX9 is a master controller in the development of teeth. It's a transcription factor that orchestrates the formation of tooth buds in the embryo. Mutations in this gene can cause teeth to be missing entirely, or to come in oddly shaped. What the researchers found was that a particular variant, not a mutation that breaks the gene, but a subtle tweak in the regulatory region just next to it, changes how the gene is expressed during the formation of your permanent teeth. Essentially, it dials down the growth of the lateral incisors just a fraction, or nudges the roots of your central incisors to spread apart slightly. The result, decades later, is a gap you can slide a credit card through. Now here's where I got genuinely excited. The team didn't stop with Europeans. They compared their findings with genomic data from populations in Africa, East Asia, and the Americas, and the same variant showed up everywhere, but at very different frequencies. In the British sample, about 8% of people carried the gap-associated version. In West Africa, that number jumped to over 45%. In East Asia, it was around 15%. So right away you can see, the gap isn't a random fluke. Its prevalence tells a geographic story. But to understand that story, I have to take you back, way back, to a time before toothbrushes, before toothpaste, before humans even had chins. Because honestly, the gap is the original smile. About 7 million years ago, our evolutionary lineage split from the line that would become chimpanzees. Chimps, gorillas, and most other apes have a striking feature, a large diastema in their upper jaw, perfectly shaped to accommodate the enormous canine teeth of the lower jaw when they close their mouths. That gap is functional, a built-in sheath for a weapon. Early hominins like Sahelanthropus and Ardipithecus still had it, their canines still prominent, the diastema still there. Then something shifted. Around 4 million years ago, with Australopithecus, canines began to shrink. Males stopped needing massive fangs to fight over mates, perhaps because pair bonding and social cooperation became more important. the diastema started to close. By the time Homo erectus strided out of Africa 2 million years ago, the gap was generally gone, replaced by a continuous arcade of teeth with no spaces. But it didn't vanish from the fossil record entirely. A 1.8 million-year-old skull of Homo habilis, unearthed at Olduvai Gorge in Tanzania, still shows a slight space between the upper front incisors, a quiet echo of a much older ape toolkit. For most of human evolution since then, having a gap has been the exception, not the rule. Neanderthals, our close cousins, also lost the diastema. Their canines were small, their teeth arranged without a front gap. But here's the twist. It never fully disappeared. And that's because evolution doesn't aim for perfection. It works with whatever variation is lying around. So the genetic instructions for building a diastema, that old ape toolkit, still lurked in our DNA, just dialed down. All it took was a few changes in the regulatory settings of genes like PAX9 to bring it back into view. Now, I said earlier I'd tie this to sweat glands and thick hair. This is where things get truly strange, and it all revolves around a different gene, EDAR. You might remember EDAR from a famous discovery in 2010, when researchers sequenced the genome of a 4,000-year-old tuft of hair preserved in permafrost on Disko Bay in western Greenland. That hair came from a man who belonged to the ancient Sakak culture, a Paleo-Eskimo group, and scientists named him Inuk, the Greenlandic word for human. His was one of the first ancient human genomes ever sequenced, and when they peered into his DNA, they found he carried a variant that caused shovel-shaped incisors, thicker hair shafts, and extra sweat glands. That variant, known as V370A, is incredibly common today in East Asians and Native Americans, over 90% in some populations, and it arose as a single mutation about 30,000 years ago, somewhere in the frigid landscape of Northeast Asia. The evolutionary logic is compelling. Thicker hair and more sweat glands are both adaptations to the bitter cold of an ice age, because thick hair retains heat, and extra sweat glands help with thermoregulation during intense hunting. Counterintuitive, but it works. And along for the ride, because the same gene controls the shape of your teeth, came shovel-shaped incisors and, in a small but noticeable subset, a reopening of the midline diastema. So if you have East Asian ancestry and a gap between your teeth, there's a chance you are carrying a piece of DNA that helped your ancestors survive the last glacial maximum, a time when enormous ice sheets covered much of the northern hemisphere and temperatures plummeted. That gap you see in the mirror is a souvenir from the Pleistocene. But what about West Africa, where the gap is not just common, but celebrated? There, the genetic picture is different. The PAX9 variant I mentioned earlier is far more prevalent, likely because of a founder effect or because in some populations it provided a subtle advantage, or simply because it drifted to high frequency without any cost. In parts of Nigeria, Ghana, and Benin, a midline diastema occurs in more than half of adults, and it's often considered a mark of beauty, sensuality, and good luck. The Yoruba people have a saying that a person with a gap in their teeth is destined for a prosperous life. Some have called it the smile of the gods. For centuries, parents have smiled with relief when their child's permanent teeth emerge with a diastema. It's seen as a blessing, not a flaw. In the diaspora, the gap has been reclaimed as a powerful emblem of natural beauty. The British model and activist Adwoa Aboa, for instance, has spoken about how her diastema connects her to her Ghanaian heritage and challenges Western beauty norms. In fact, in modern Nigeria and Ghana, some dental clinics reportedly receive more requests for diastema creation than for gap closure, a procedure where healthy enamel is carefully shaped to widen a natural space or craft an entirely new one, mimicking the ideal. Meanwhile, in medieval Europe, the gap carried its own powerful symbolism. I remember the first time I read about the wife of Bath. In Geoffrey Chaucer's Canterbury Tales, written in the late 1380s, the wife is described as gat-toothed, soothly for to say, and scholars have long argued that this detail wasn't incidental. In medieval physiognomy, a gap between the front teeth was thought to indicate a bold, amorous, and well-traveled character. Chaucer used the gap as shorthand for everything her character represented. Even earlier, the 13th century text Secretum Secretorum, a pseudo-Aristotelian guide to reading human character from physical features, warned that a person with widely spaced teeth was lecherous, impudent, and greedy. The gap was read as a map of the soul, and it could damn or elevate you depending on the context. Fast forward 600 years, and the meaning had flipped. In the Victorian era, with the rise of orthodontics, any imperfection in the alignment of teeth became a target for correction. Braces, and later clear aligners, promised to close the gap and deliver a uniform, Hollywood smile. For much of the 20th century, having a diastema in the West was something to be fixed, hidden, erased. Models like Lauren Hutton, who famously kept her gap in the 1970s, were outliers. Her agency initially told her to get it filled, and when she refused, they nearly dropped her. Michael Strahan, the football star turned TV host, once joked that his gap is so iconic that he had it insured. Yet thousands of teenagers every year beg their parents for braces not because their teeth are unhealthy, but because they've been told the space between their incisors is a defect. So we find ourselves in a strange moment. The gap is both a remnant of our deep past and a subject of fierce cultural debate. Some people pay thousands of dollars to close theirs. Others use dental veneers to create an artificial gap, because they want to imitate the look of a supermodel or a singer. The same trait carries entirely opposite meanings depending on where and when you live. But there's an even deeper layer to this, one that lies in the size of our jaws and the food we eat. The presence of a diastema isn't just about genes that shape teeth. It's also about the size of the shelf they sit on. In hunter-gatherer populations with coarse, unprocessed diets, jaws tend to be longer and wider, and the teeth often have plenty of room, so spacing is common. Once agriculture took hold about 10,000 years ago, diets softened. Using 3D scans of hundreds of ancient skulls, researchers have shown that jaw size in the Levant decreased by an average of roughly 12% within just 2,000 years of farming's adoption. Jaws shrank generation by generation, but teeth, slower to evolve, stayed roughly the same size. The result, in many populations, was crowding and impacted wisdom teeth. Yet in some people, the opposite happened. The shrinking jaw combined with certain genetic variants to push the central incisors apart, opening a window that had been closed for millennia. The Harvard anthropologist Daniel Lieberman describes in his book The Story of the Human Body how the transition to farming restructured our entire face. Narrower dental arches, shorter palates, and a surge in malocclusion. For a subset of us, the diastema isn't a holdover from Lucy but a side effect of the agricultural revolution. And that brings me back to my own spit. A few months after reading the study, I did something I never thought I'd do. I requested a raw data download from my consumer DNA test and looked up the precise chromosomal location where the PAX9 variant sits. It took some digging. I had to cross-reference the scientific paper's SNP identifiers with my own giant spreadsheet of A's, C's, G's, and T's. But eventually I found it. I sat at my laptop late at night, scrolling through thousands of rows, a mug of cold tea at my elbow, and there, in the column for my genotype, I saw 2 copies of the variant that the study associated with increased likelihood of a gap. I won't pretend I wasn't thrilled. It was like reading a tiny line from a history book written in my own cells. But, and here's the thing, that variant is just one piece. The study found that even with those 2 copies, my odds of having a diastema were only about 35%. The rest came from the 100 other variants, plus non-genetic factors like the size of my jaw, the position of my tongue, whether I sucked my thumb as a kid. Genetics, as the saying goes, loads the gun. Environment pulls the trigger. Still, I couldn't shake the thought that specific stretch of DNA has been passed down, generation after generation, through a chain of ancestors I will never know. Some of them smiled with a gap exactly like mine. Others didn't, but they carried the silent code and handed it on. I remember being 7 years old, sitting in a vinyl dentist chair while the orthodontist told my mom I'd definitely need braces by 12 to close that space. The dental assistant rolled her eyes when I said I didn't want them. "You'll regret it when you're older," she said. But we moved house, the braces never happened, and my gap survived. And one day, roughly 8 years ago, I smiled for my first YouTube video, and a commenter wrote, "You should get your teeth fixed." I didn't, obviously. And now I have a whole evolutionary narrative to back up that decision. So what does this mean for you, the person watching this, who also has a gap, or who loves someone with one, or who just wants to understand why humans are endlessly varied? I think it offers a quiet lesson. Our bodies are not blank slates. They are archives. The features we sometimes dismiss as quirks or flaws are often the most visible clues to an epic journey we weren't even aware we took. Your gap might trace to a mutation that helped your ancestors survive the ice, or it might trace to an ancient West African founder who passed it on to millions. It might be both. The DNA doesn't give you a single, neat origin story. It gives you a mosaic. And that, to me, is far more interesting than the myth that a gap means you're especially lucky or especially lustful or descended from a specific tribe. The real story is bigger than any of that. It's about gene regulation, plate tectonics of the human face, and the slow, blind creativity of evolution. Now, I said I'd leave you with a question rather than a tidy answer. If you have a gap, do you feel proud of it? Do you want to close it? I can't tell you what to do. But the next time you look in the mirror and see that little space, I want you to think about the glaciers, the medieval poets, the apes, and that one tiny change in a regulatory region on chromosome 2 that decided, for no reason at all, to keep your teeth company apart. Because that's your story. This video was made possible by Babbel, the language learning app that helps you speak a new language with confidence. If you're like me, and you've always wanted to read Chaucer in the original Middle English, or to understand the geneticist's papers in German, Babbel's bite-sized lessons are designed by real experts and fit into your day. There's a link in the description for a special discount. Go check it out. And before I go, this whole journey made me wonder about other features people notice in their own faces. Tell me in the comments, do you have a gap, and has anyone ever told you it meant something? I read every one, and I might just make a follow-up about the weirdest beliefs around teeth. Until next time, keep smiling, however your teeth are arranged. Thanks for staying until the very end. Goodbye for now.